All right, today we're going to continue to work on Unit 4, dealing with quadratic equations. I have split this lesson into 2 days. Today we're just going to work on factoring, difference of squares, trinomials without leading coefficients, and greatest common factors. In the next lesson we will continue this one and look at factoring trinomials with leading coefficients. They're a little bit trickier, so we want to make sure that you have a good handle on just basic factoring to begin with. What I have included in Moodle is a PowerPoint page that you can download and print off. It's a good thing to have in front of you. It's a flow chart, kind of lets you see where you should go next. So when you are working with this flow chart, the very first thing you want to look at is starting right here. This is your starting place. And depending upon the answers that you get, you're not sure where you might end up. So the question is there a GCF in this quadratic that we're looking at right now? So if you look at the two terms, our first term is 5x squared, and our second term is 20. The question there is there a greatest common factor between 5x squared and 20? And they don't both share a common variable, but between those two terms, there is a GCF of 5. So the question is there a GCF? So our answer here is going to be yes. So we need to figure out what the GCF is. It's 5, and you need to factor it out. So we're going to factor it out, and the question you ask yourself is 5 times what gives you the 5x squared? That's where the x squared is going to come into play. Whatever sign that was originally there, which you now can't see, but it was a plus sign, just gets carried down. And then the next question is 5 times what gives you the 20? And that's where our 4 is going to come into play, because 5 times 4 is 20. So we go ahead and factor out the GCF, and then our next question that is presented to us is how many terms are there? So there are 2 terms, so we're going to follow our flow chart up here. Is each of those terms separated by a subtraction sign? No, this particular one has an addition sign. So since our answer is no, we are finished, because there's no such thing as factoring a sum of squares. It's only a difference of squares. So that is an example of a sum of squares that had a GCF, and so that's the only thing we were able to factor out. Now, if we change that problem just by a little bit, notice the only thing we've changed here is our plus sign became a minus sign. We're still going to start right here at this box. Ask yourself whether or not there is a GCF, and we feel that there is a GCF between the values of 5x squared and 20, and the GCF is 5. If you factor that 5 out, you're going to be left with x squared, and that's because 5 times x squared is 5x squared. We're going to bring down that minus sign, and then we have to fill in this gap here. So 5 times what gives us 20? And the answer to that is 4. So along the lines of asking yourself if there's a GCF or not, you say yes, you figure out what it is, and you see what's left. Now we go back to our next question. How many terms are there? If you'll notice, there are 2 terms. So we're going to come up here. Is each term separated by a subtraction sign? It sure is. So we're going to continue up here to the yes box. And then ask yourself, is each term a perfect square? Now just for review, a perfect square is when you can multiply the same thing times itself to get that value. So x squared is a perfect square because x times x is x squared. 4 is a perfect square because 2 times 2 is 4. So then our answer to this is yes. And then that tells us that we are going to factor this one using a difference of squares. And so this GCF that we pulled out becomes the 5. These sets of perfect squares here become the factors. Once you're going to add them, so we have x plus 2. And the second time we're going to subtract them, and that's where we're going to get x minus 2. Now, none of these individual factors that are put in parentheses can be factored further, so you are now officially finished with that particular problem. Okay, so we're going to leave the problems that have 2 terms in them, and we're going to move on to the ones that have 3. So again, like always, we start at the beginning. Is there a GCF? Is there a number or variable that's common to y squared, 16y, and 64? And the answer to that would be no. So then you're going to ask yourself, well, how many terms are there? And in this case, we have 3. Is there a leading coefficient? By leading coefficient, we are talking about a number falling ahead of the largest degreed term. So is there a number in front of that y squared? The answer to that is no. Alright, so we take our flow chart over here. And now what you need to do is list all the factors of the last term. So our last factors is 64, so we're going to do 1 and 64, 2 and 32, 3 and nope, 3 isn't going to work, 4 and 16, 5 isn't going to work, 6 isn't going to work, 7 isn't going to work, and 8 is our last one, because 8 times 8. So you make sure you list all your factors. If you do it in order, you'll notice 1, 2, 4, 8, and then you loop around and you go up. Once you find this matched point, it doesn't actually have to be the same value, but you know, if it could be 4 and 6, or the 2 that link up together, you know that you're finished and that you found all the possible factors. So, once you have your list of factors, we're looking for the right combination that does the second sign. Here's our second sign. So we're looking for the combination that you can add to get us positive 16. So out of these numbers in here, which one gives us 16? This is going to give us 65. So we don't want this one. This one's going to give us 34. Okay, so we don't want this one. We're going to get 20 here. And then, of course, you get 16 here. So, we found the right combination. And so this 8 and 8 are going to be our factors. So if you started out with y squared plus 16y plus 64, your factors are going to be y plus 8. And then it'll be the exact same thing, y plus 8. Now if you're working with an SOL or some other multiple choice thing, even though this is the correct answer, because you have the same thing written twice, this would be equivalent to y plus 8 squared. Alright, so let's try another example. Here, is there a GCF? No. How many terms are there? 3. Is there a leading coefficient? No. So we're right back where we were in the last one. We're going to find all of our factors of 42. We have 1 and 42. We have 2 and 21. 3 and 14. 4, no. 5, no. 6 times 7. Now I know I'm done because the next term is already being picked up in the second column. Alright, so here are my factors. Find the combination that does the second sign. So I'm looking for factors that that subtract to give me a -1. So we know we're going to be working with 6 and 7. Okay, so it's going to be x with the 6 and x with the 7. And think about this thing right here. How do you get a negative product? The only way you can get a negative product is if you're multiplying a positive times a negative. And we want our larger number to have this one. So the negative is going to go to the 7, and the positive is going to go to the 6. And so our factors of x squared minus x minus 42 is x plus 6, x minus 7. Alright, so now what we're going to do is look at this one right here, where we have m squared plus 8m minus 65. Is there a GCF? No. How many terms are there? 3. Is there a leading coefficient? No. So again, we're down here. So we're looking for all the factors of 65. 1 and 65. 2, 3, 4, 5. So we have 5 and 13. 6, no, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Nothing seems to be working. So let's see if we can find what we need based off what we have. We're looking for two numbers that subtract to give you 8. Alright? Excuse me. So we have the 1 and 65 and the 5 and 13. The combination that subtract to give me the 8 are the 5 and the 13. And we want our larger number to get the positive. So that's going to be m plus 13 of course, and m minus 5. Alright, hopefully we're getting the hang of this by now. We're going to move on to number 6. We're looking for two numbers that you can multiply together to give you 4 that you can add together to give you 2. So we have 1 and 4, 2 and 2. So we looked for a GCF. No. There were 3 terms. Is there a leading coefficient? No. So we went straight to this right here. However, you'll notice that neither 1 and 4 can you add together to give you 2, or 2 and 2 can you add together to give you 2. So this one is a special case, and you write the word prime. Alright, so this is going to take us to our very last problem, example 7. List your factors. We'll go through. Is there a GCF? No. How many terms are there? 3. Is there a leading coefficient? No. List your factors. We have 1 and 28. We have 2 and 14. We have 4 and 7. So which combination here is going to add up to give us negative 11? 4 and 7, so you get x, and then the minus 4, the x minus the 7. Okay? And neither one of these can factor again. You go through the flow chart very quickly and notice that nothing allows you to factor x minus 4, nor will it allow you to factor x minus 7. I hope this helps. If you guys are struggling with any of this, please email me and I'll be glad to work with you on the computer. Thanks.